So hello everyone, my name is Sergey Simorenko. I'm from a company called Bohemia Automation, and today I'm presenting technology which called data diodes, and we'll talk about it, how it can be used in industrial automation, how it can be used to secure networks, and so on. So let's start. So problems of isolation of bidirectional networks is usually that consuming application may have security problems. So despite you firewall everything, you block everything, but you have some consuming application, and it has can have some backdoors, can have some code problems, and because of that attackers can execute some code in your system. Despite of like firewalls and operating system network stack is usually stable, it can still contain some exploits and unsecure code, so there is a chance that a network can be broken just with breaking firewall. Of course, there is human factor. System administrator can just make mistakes and accidentally turn off firewall settings or something similar, and or accidentally delete some rules, and network becomes vulnerable. And there is, of course, point of higher maintenance costs, because you need to have some system administrators, you need to have some development operators which actually maintains this network and need to be paid, need to be need to perform regular checking of security, so the solution is, sometimes when you need only unidirectional network and you're happy with this, you can go with data diodes. So data diode is a device which turns your network physically unidirectional. It can be compared like with some radio channel where you have only receiver, but you don't have any transmitter, and other side has got no receiver at all. So if other side has no receiver, you just can't send anything there. Like positive side of this is higher security, because there is no known way to break like physical layer when transmissions is physically impossible, and lower maintenance cost, because you can just install this data diode and it will work for years. For dozens of years, you don't need to change it, just to maybe to replace to have higher network speed. But there are negative sides, because data diodes are harder to understand, it's harder to plan network topology, and there is no compatibility with popular network protocols. So let's deeply review unidirectional networks. So what you can do with them? You can collect telemetry and real-time monitoring, of course. If your applications just collect telemetry and don't send any control commands, for example, to fieldbus network, you don't need to have a bidirectional network. It's also good for audio-video transmission, as usually you have you need only to record, and you don't need to send anything back. So, like in our case, when we are talking here, of course it's bidirectional, but imagine that I'm talking solo and you have no permission to talk, so it can be unidirectional network, because my video stream is going to your computer and you don't need to transmit anything. It can be used for secure log collection, for one-way database replication, and some other monitoring one-way synchronization cases. Some implementations. Let's review some implementations. So you can go with hardware solution from big vendors like Siemens, Bayer, or ST Engineering. There are a lot of them, and they usually provide you with some proxies, with some techniques for proxying like real normal network protocols. But of course you can go with do-it-yourself solution and just create a data diode for with twisted pair or optical fiber. It's actually really easy to create something with twisted pair. You need just to connect transmitters like in loop to your receivers to cheat your network hard that a link is established and connect receivers to other side. So let's go next, and problem of standard protocols when you go with unidirectional network. So there's only UDP, IP, and one-way ICMP practical available. There is of course like some other network protocols. You can go, you can try going with some routing protocols with something else, but practically you have only UDP and ICMP. TCP connections to protected network cannot be established. That's the major problem, because half of protocols are TCP based, and TCP connection from protected network can be established with some workaround, actually with cheating the transmitter that connection is established and creating some TCP to UDP proxy. And the only one protocol practically useful for data transmission is UDP. So how it works? Like push protocols, they work always if you have push protocols UDP based, which doesn't need any confirmation, so you are lucky to go with unidirectional network. You can install data diode and it works out of the box. Examples can be SNMP traps and syslog via UDP, so they don't need any confirmation and they just work. Certain video audio protocols, they also don't need you to establish some video link or audio link, so if you don't need to have some signaling protocol like you have in classic IP telephony, you can go with unidirectional network also out of the box. Other push protocols just require you to, of course, if they don't need any confirmation, they just require you to collect TCP data and package as UDP packages, and of course you can also give some acknowledge for that, and you can push. For example, you can go with SMTP, you can go with the NNTP, you can go with FTP if you need to upload something regularly. You can go with Git if you need to push only something, and certain database application protocols are also push based. Push adapter example is really simple. So the only problem is the client never knows that the message has been really received. So actually proxy responds to it that I got your message, it sends it via data diode to other side, and but there is no response neither to proxy nor to client that message has been physically received. We can for this we can also implement data integrity checking. So if you go with encryption, you can go without, like checksums. So you can go, easily go with signatures. But for encrypted protocols, it's better to have some checksums to make sure that everything goes fine. To be honest, I've seen only a couple of cases when network traffic was broken. It was always because of broken network equipment, but to avoid this, it's better to add some data integrity. So pulling data is more complicated. It requires actually push replication one way So the majority of standard protocols used, for example, industrial automation, they work this way. So if you have a data diode which allows you to, for example, collect data from Modbus, it physically replicates your Modbus context to other side, and the other side provides you Modbus server when you can collect this data. Everything is actually simulated on both sides. So one side simulates client, which collects data. After it replicates it to other side, and other side must simulate server to let it be compatible with your existing software. So how it works, we have automation platform EVA ICS. Our company provides a community edition, and data diodes work even in community edition out of the box. So we have two ways how to create unidirectional replication, and it has been tested with hardware data diodes and works just perfectly. So the first way is to put like node A behind data diode, and via PubSub server replicate everything to node B. So all objects will be replicated from node A to node B. For example, you have some sensors, you are collecting some telemetry on node A, and the operators working with node A locally, like they have some operation point here, and after it goes to node B in some external network, as this node B has no physical access to node A and the internal network. There is also a way to synchronize fieldbus only via data diode. As another example, you can just put data diode between fieldbus and your node. You create so-called like node twin, and it replicates all objects between node twin and real node. The practical approach of this example is that operators between nodes can still communicate between each other, but fieldbus is fully protected. And so it works pretty easily. It works out of the box, and you don't need to proxy any fieldbus protocols, because EVA ICS does everything by itself. Let's talk a little bit about UDP pulse synchronization in high-loaded system. So basically, what we need, how do we encapsulate this traffic to UDP? First, you can buffer easily your telemetry up to MTU. So don't send like small packets, you can send one big packet with MTU collected. So how to packet? The first is if you are sending data in JSON, so it's pretty easily. You can go with ND-JSON if your parser allows this, or just manually form an array, adding commas, adding brackets between, and sending this to other side. Message pack a little bit more complicated, but also actually easy. Consider you have a vector of data, you just increase this vector with new telemetry data, and after you put just at the beginning DC or DD, these are prefixes of message pack array and actual array len, and other size easily unpacks this. With protobuf it's a little bit more complicated because it depends on parser implementation. To be honest, I tried several parsers, and I had only one parser working properly when you put more than one object in a buffer and tries to deserialize it. You can also go with some custom data serialization algorithm, and another question is about compression. When you are going to send UDP, especially when you are going to send it via public network with some bandwidth restricted network, you need to compress it. So before, but you need actually to go up to MTU to make sure that your compressed data is less than MTU, and but big enough to be practically useful. To do this, we calculate data entropy before sending it, and entropy algorithm are just perfect. For example, Shannon entropy algorithm is about 10 times faster than regular data compression, like with the simplest gzip. But sometimes, of course, it gives you wrong values, so better to go with like 60% of MTU, but it's still much better that having no entropy calculation, because usually if you replicate telemetry data, it compresses pretty nice. Some complex architectures. With data diodes, you can implement, for example, classic Bell-LaPadula model. It's a little bit harder to understand. It was used in like probably 70s to restrict document flow between different operators with different level of access. Of course, in like modern days, it can be used to, for example, you can collect data from customers in some clouds, server, having no access to like this cloud server has no access back, and after you can replicate your database for some analytics to operators having no access to real database, like physical access, and in case of your operator analytics center has been compromised and database is corrupted, you always have like 100% insurance that you have a working database copy and its backups, and they have been physically untouched. So despite of this model can be a little bit ancient, with some modifications, with some practical appliance, it can be used to some modern tasks. You can of course go with triangle, you can go with some wired rings, and it's completely up to you. But in all section, when you need read or write only access, it's better to install hardware data diode, and it will go much more secure. So actually we are finished, and let's ask maybe some questions. You can ask in chat, or you can turn on your microphone, and thank you for listening. Let's wait about maybe 2 minutes. If there will be no questions, let's finish for today.
So I have one question. Can you tell us, please, about the cost, approximate cost?
That's a good question. Actually, I forgot to mention cost of the solution. So if you go like with vendor solution, it can cost from like 1,500 euros up to unlimited, probably, because I've seen devices which cost about 10,000 euros or pounds or dollars. And but if you go with do-it-yourself solution for 100 megabits, it costs you almost nothing. You just need to have two network connectors, and you need to have a piece of data cable, like twisted pair. The problem in do-it-yourself solution is, of course, that you need to set up it properly. You need to, for example, you need to be keen on networking a little bit. You need to put ARP settings properly, because there is no ARP discovery as well in such networks. and you need to actually plan everything and put everything by yourself. The only problem I never, as I mentioned, I have no experience with optical do-it-yourself solution, because I've been working always with like vendor solution in optical, with optical diodes. But I guess it should work also out of the box, and the benefit of optical that you can go with like 1 gigabit and higher speeds, and usually it will cost you about maybe with like all optical to twisted pair conversions and cables, it will cost you maximum 100 euros, maybe 100 and half. With like vendor solution, it can cost you a lot, but you are paying for protocols. So if you need to proxy something really like complicated, some video recording, some I don't know. Actually, what EVA ICS Computer Edition doesn't provide. So you may go with higher prices.
Okay, thank you.
Or of course,
this is one of the main reasons.
Yeah, of course you can implement this by yourself, but the most problem is that people just don't understand this technology. They underestimate this technology, and but sometimes it's just unbreakable for just the perfect thing for some mission critical system. For example, you can easily install it on nuclear plant, you can install it on some defense plants, and you are 100% sure there is nothing can be attacked unless attacker physically connects your cable.
Okay, thank you.
Okay, you're welcome. So if there is no, so I see a hand, Pavlo, please.
No, I don't have any questions.
Okay.
It was asked then.
Yeah, but nice to see you. Yeah. Okay. So then let's finish for today. Thank you everyone again for watching this, and see you next time on Cyber Scotland.
Thank you.
Goodbye.